Hi friends, till now we are aware with the definition of data mining, data warehouse and two different terms OLTP and OLAP that we have discussed or learned in last two chapters. In this chapter, we'll discuss data preprocessing. What is data preprocessing and why the data preprocessing is required, that we can understand with the help of an example. Suppose a manager of all electronics that have been charged with analyzing the company data with respect to the sales at a branch. He carefully inspects the company's database and data warehouse. Do you know the difference between database and data warehouse? Identifying the dimensions to be included, such as item, price, and unit sold. He noticed that several of the attributes for various tuples have no recorded value. For analysis, he would like to include the information. In other words, the data he wished to analyze by data mining technique is incomplete, noisy or inconsistent data. So he has to complete the data by putting some standard values, he has to remove some redundant data, and he has to remove some inconsistent data that is not required. This is data preprocessing. For doing the data preprocessing, we require the number of steps. The first step is data cleaning. Data cleaning routine work to clean the data by filling in missing value, smoothing the noisy data. If users believe that the data are dirty, they are unlikely to trust the result. Furthermore, dirty data can cause confusion for the mining procedure. Results are unreliable and output will also be unreliable. Although most mining routines have some procedure for dealing with incomplete data, they are not always robust. Instead, they are concentrate on avoiding or fitting the data to the functions being modeled. Therefore, a useful step is to run your data through some data cleaning routines. We have some data mining functionality. In the data mining functionality, we have some inbuilt data cleaning routines. The next step is data integration. Yet some attribute representing a given concept may have different name in different database, causing inconsistent inconsistencies and redundancy. For example, the attribute for customer identification may be referred in one database as customer ID, or in other data stores it can be cust ID. And the same way, the first name of a person could be registered as Bill in the one database, William in other database, and third have the large amount of redundant data, because having the large amount of redundant data may have slowed down or confused our knowledge discovery process. Next is data transformation. Getting back to your data, you have decided that you would like to use a mining algorithm for your analysis, such as neural network you can use, nearest neighbor classifier you can use, clustering we can use. Such method provide better result if the data to be analyzed have been normalized. In the normalization in database, we have heard about the terms first normal form, second normal form, third, BCNF and all. Example, contain the attribute of age and annual salary. The annual salary attribute usually take much larger value than age, because in the age maximum we can take 3 digit of number. If the attribute are left unnormalized, the distance measurement taken on annual salary will generally overweight or distance measurement taken on age. So there could be a confusion, either we have to take the difference between the age or we have to take the difference between the annual salary. So the transformation of data is very important aspect of data warehousing. Data reduction. There are number of strategies for data reduction. These include data aggregation, building a data cube. Here we can separate the data on the basis of the department. Attribute subset selection. Here we can select the data or reduce the data on the basis of the important attribute. Dimensionality reduction using the encoding scheme such as minimum length encoding. How many number of dimension, 1 dimension, 2 dimension, 3 dimension, number of dimension we can include or reduce. And numerosity reduction, replace the data by alternative smaller presentation. Here we can put the value in terms of first, second, third, or data can also be reduced by generalization with the use of concept hierarchy, where the low level concepts such as city for customer location can be replaced with the higher level concepts such as region or states. So these are the four basic terms that we use for data preprocessing. First is data cleaning. In the data cleaning, we have to clean the incomplete data, ignore the data, or we have put some standard value. Next is data integration, where we have to combine from different sources of the data into a data warehouse. Next is data transformation, where we have transformed the different resources of the data into a number of attributes we can select, number of dimensions we can take, and then we have to reduce the data for our task. First is data cleaning. Here, because we have already discussed data cleaning, again we are going to discuss the data cleaning. What is the difference between data cleaning there and here? There we have discussed what is data cleaning. Here we are going to discuss the method we will use for data cleaning. Real data words tend to be incomplete, noisy, and inconsistent. Data cleaning routine attempt to fill in the missing value, smooth out the noisy values while identifying outlier and correct inconsistencies in the data. First is missing value. Ignore we have number of options to clean the data. First option is ignore the tuples. This is usually done when the class label is missing. It means if we don't have the attribute name or the class label is missing, this method is not very effective unless the tuple contains the several attributes with the missing value. It is especially poor when the percentage of missing value per attribute varies considerably. Second method is fill in the missing value manually. When this is the second option, we can fill the value manually where the data is incomplete. Third is use a global constant to fill in the missing value. Here we can replace the example. We can replace the unknown value with the infinity. We can replace the missing value, some standard value. We can replace with the symbols also. Use the attribute means to fill in the missing value. For example, suppose that the average income of all electronic customer is $56,000. Use this value to replace the missing value for income. It means if somewhere the salary of the person is not given, then we can put the salary of the customer is $56,000. Use the attribute means for all samples belonging to the same class as the given tuple. Example, if classifying the customers according to the credit risk, replace the missing value with the average income value for the customer in the same credit risk category as that of the given tuple. It means if the customer has taken some loan and if you don't know the income of the person, then as per their designation, as per the company, as per the income, we can credit risk with some standard value or standard average income we can put. Use the most probable value to fill in the missing value. This is the other option. This may be determined with regression, inference based tool using a Bayesian formulas or decision tree induction. For example, using the other customer attribute in your data set, you may construct a decision tree to predict the missing value for the income. What will be if the person of age is 40, or if the person has a 10 year of experience, what would be the expected salary of the person, that we can replace with the probable value. This is some example of putting or cleaning the noisy data. Noisy is a random error in a measured variable given a numerical attribute such as price. Now smooth out the data to remove the noise. Store data for price dollar. These are some data, and that we have to store the data in a ascending order. Then partition the data into number of bins of same size. In the bin 1 we have 3 value 4, 8, 15. In bin 2 we have again 3 value 21, 21, 24, and again in the third bin we have 25, 28 and 34. Smoothing these values by taking the mean value of a particular bin. From the bin 1 we will get the mean value 9, so we replace all the values with the 9. In bin 2 we will get the mean value of 22, so we can replace the all value with 22. In bin 3 we will get the mean value, that is 29, and we can replace all value with the 29 if these values are coming. Smoothing by the bin boundary, we can replace the value by the minimum value of the bin or the maximum value of the bin. So we can replace, we can put 4, 4 and 15, or we can take starting value 21, 21 and 24, and then we can take 25, 25 and 34. These are the three different methods of replacing the noisy data. Binning method smooth a stored data value by consulting its neighborhood, that is the value around it. The sorted value are distinguished into a number of buckets. Clustering means we are grouping the similar kind of values. Value that fall outside of the set of cluster may be considered into the other cluster. Regression, here we can use two different type of regression. One is the linear regression, second is multiple linear regression. Linear regression involves finding the best line to fit two attributes, so that one attribute can be used as predict. In the multiple layer regression, it is an extension of linear regression where more than one attributes are involved and data are fit to a multi-dimensional surface. And last is combining the computer and human inspections. Outlier may be the identified through a combination of both human and computer. Data integration and regression is a second steps of data preprocessing. It includes the data mining, offer required data integration. It means the merging of data from multiple data stores. Here we can put different types of data into a single place. The data may also need to be transformed into form appropriate for mining. Whichever form you feel free, you can take for the mining. Next is data integration. It is likely that your data analysis task will involve data integration, which combine data from multiple sources into a coherent data store as in data warehouse. Thank you. This is all about data preprocessing. Thank you.